Hello everyone, this is Team Kalis. Today we are going to do a final presentation on the conceptual design of a two-seater light sport aircraft. So we have named our team as Kalis as it's another name for the sky god, the Greek sky god, Kalis. So our team includes Zayan, myself, Jagrat and Smritimala. We have two wonderful mentors, Tejas sir and Aditi ma'am. Today, this is what we are going to do in our presentation. We are going to talk about the forces acting acting during the flight of an aircraft, the outlining of an LSA, the stages of aircraft design, the initial weight estimation, the constraint analysis, and the wing platform parameters. Over to you, Smritimala.
Yes. So there are four forces which act on an airplane. They are lift, weight, thrust and drag. So now let's see what these forces are. First of all, weight. Weight is a force generated by gravitational attraction of the earth on the airplane. Next, lift. Lift is a force that directly opposes the weight of an airplane and holds the airplane in the air. It is produced by the motion of airplane through the air. So next, drag. It is the force that resists movement of an aircraft through the air. Thrust. Thrust is a force needed to overcome the resistance of air to the passage of an aircraft. It is generated by the engines of an airplane. Lift and weight always act on upward and downward direction respectively when thrust and drag change their direction according to the direction of aircraft. So, next one question comes in our mind: how does an airplane fly? So, there will be a relative motion between the air and the wings of an aircraft. This relative motion leads to the generation of a pressure difference between the upper surface and the lower surface of the wing. So this pressure difference leads to the generation of a net force. So a component of this net force acts in the vertical direction and is called as lift. So let's see the outline of light sport aircraft. Light sport aircrafts are lightweight and easy to operate. They are used for hobby flying, recreational interests. So according to Federal Aviation Administration, certain standards of requirements are to be met by LSA. They are: only 2 people can occupy in this aircraft. The cabin of LSA should be non-pressurized. It should have single propeller engine. Maximum takeoff weight is 1320 pounds. Maximum stall speed is 45 knots. So the LSA category covers a wide variety of aircraft including airplane, gyroplane, lighter than air, weight shift control, glider and powered parachute. So according to Federal Aviation Administration, airworthiness certificate for a light sport aircraft are issued under 2 categories. One is the special light sport aircraft and the other one is experimental light sport aircraft. So there are 3 stages for the design of light sport aircraft. One, conceptual design, preliminary design and detailed design. Conceptual design is the first stage of aircraft design. In this stage, rough sketches are created with respect to the aircraft's configuration. The designers achieve a design that meets all the aircraft requirements. This phase formally establishes the initial idea. Next comes preliminary design. Preliminary design ultimately answers whether the idea is viable. It ensures that the idea is integrated properly into the structure. So it exposes potential problems as well as possible solutions. So the next one is detailed design. So this process primarily involves the conversion of preliminary design into something that can be built and ultimately flown. Over to you, Anirudh.
Thank you, Smritimala. So the weight of an aircraft is subdivided into 4 other categories, which is the empty weight, the fuel weight, crew weight, and the payload weight. So the total weight of the aircraft is summed as the empty weight, the fuel weight, crew weight, and payload weight. So the empty weight is nothing but the weight of the structure of the aircraft without the fuel and the payload of the crew. The fuel weight fraction, which is WF by W naught, is 1 minus the total weight of the change of the total weight of the aircraft. So how we calculate this is that we first take a mission profile, and then from there we take all the changes of the aircraft during different maneuvers, and then we find this fuel fraction. So the crew weight we have taken as 140 kgs and the payload weight we have taken as 20 kgs. Also, the fuel weight fraction is the only weight that changes during the aircraft. The mission profile is nothing but a representation of an aircraft flight at different moments. It is used to visualize the flight and consider the change of weight during the aircraft flight. So this weight change occurs due to the fuel consumption. So we have taken the different. We have taken the mission profile as a simple one for our LSA, and these are the weight. These are the change of weight during each maneuver. The empty weight fraction, WE by W naught, can be viewed as A multiplied by W naught, which is the total weight, raised to the power of C. So these A and C values we have taken from our literature, and with all this together, we are able to do this process called initial weight estimation. It is nothing but the estimation of the aircraft weight involving the repeated iteration of the estimate of the weight required during each design stage. For conceptual design, we only use initial weight estimation. The other weight estimation methods, the detailed weight estimation, which we use in the preliminary and detailed design stages. By iterating this formula repeatedly, we have found the final maximum takeoff weight as 507.86 kilograms. Over to you, Javed.
So, constraint analysis is an analysis of the performance requirements of aircraft. It's an important step of aircraft design. It's necessary so that we can find the optimal T by W, or the thrust to weight ratio, and W by S, that's wing loading. For our constraint analysis, we have taken four constraints: ROC constraint, cruise constraint, takeoff constraint, and landing constraint. Now, going next to the equations, all the equations have been taken from the literature that has been mentioned below. So, to perform constraint analysis, we have taken this data, that is cruise velocity, rate of climb, air speeds, drag, minimum drag coefficient, aspect ratio, sea level density, maximum lift, Oswald efficiency factor, acceleration due to gravity, takeoff and landing distance. So by performing the constraint analysis, we have come to the conclusion using this diagram. Anirudh, can you go back to this? In the graph, the landing constraint shows the maximum W by S for landing. All the other curves, however, show the minimum T by W required for the phase. Therefore, our feasible region would be above the ROC constraint curve and to the left of the landing constraint curve. The green circle shows the optimal design point with a T by W of 0.28 and W by S of around 325. So, wing planform is basically the shape of the wing. We have taken these parameters, that is, S is the wingspan, B is the wing area, aspect ratio, and length of the root chord, length of the tip chord, and the taper ratio, that's the ratio of the root and tip chords of the wing. By performing constraint analysis, we have come upon these values and we have created the design of the wing. As you can see here, by performing all of this, we have come upon results like familiarization of conceptual design process for an LSA, first estimation of the maximum takeoff weight from weight estimations, that is 507.86 kg. From constraint analysis, we have got thrust to weight ratio as 0.27 and wing loading as 325.4. Then required thrust is 1345.17. Wing area is 51.31 meters square. Wing platform is trapezoidal wing with a taper ratio of 0.45. So we have taken all of what I've seen, what we have done from the reference. So these are the textbooks we have used. So I would like to thank Tejas sir and Aditi ma'am for helping and guiding us throughout this JSS batch 2. We would also like to thank our parents who enrolled us for this amazing experience and provided motivation and support when we needed it the most. Thanking you for being with me till the last, and thank you for the team also. And I would also like to thank Tejas sir and Aditi ma'am for helping us throughout the journey. Thank you.
Thank you, Javed. We are now open for questions.
Okay, thank you so much, team. That was a really intense presentation. We do all this process in engineering, and I know what you guys were talking about, but then you guys have done it so just now itself in your 9th and 10th, 11th, 12th standards. That is really impressive and amazing work.
Yeah, this is Sudarshan, one of the parent of a student who is enrolled for
please.
this. Yeah, the young team. I don't have questions, but I would like to put my opinion out. Yes, the young students have done a fantastic project. I think at this age, it's great to see such an effort, and the organization is doing equally effective initiative. I really thrilled or overwhelmed to see the presentation. It was a fantastic presentation. Thank you. All the very best for your bright career.
Thank you, sir.
Thanks, sir.
Thank you so much, sir.
I have a question. So
Yes,
you
sir.
have designed the wing. So this wing is gonna go for your two-seater aircraft, if I'm not wrong, right, students? So what is the next element that you would like to focus on, or even on this element, have you compared with any other aircrafts and found that whatever values that you have got telling this is my wing area, this is how big it should be, this is the size it should be, and are these ideal when you compare to the existing airplanes and their wing area and sizes?
Ma'am, the values which I got from our analysis, it was actually from we got it from the higher end of like most aircraft. We didn't get like in the average of the other values we have got. So this is because of our limitation of data, like because we have taken a fewer aircraft, and also because we have taken the some of the factors as an overestimate or an underestimate. So this has caused us to get slightly higher values than what an LSA usually has.
So you may want to do more iterations to find the right value and then build on it, is it?
Yes, ma'am.
All right. Good work. All the best.
Thank you, ma'am.
Thank you, ma'am.
Thank you, Nikita.